example. Now we take an example so that we have some idea how we can use the concept of minimum variance unbiased estimator in multi-parameter case. So we take an example, that is, suppose that we have the random samples from the distribution, that is from uniform distribution, and it is theta 2 minus theta 1 raised to power minus 1, and it has range from theta 1 to theta 2. And we also assume that the y1 and y2 are representing the minimum and the maximum distribution of the ordered statistic, and we assume that they are jointly sufficient statistics. So here we are not actually going to prove that y1 and yn are the jointly sufficient statistic, but that is the part of that the question. But here we assume, because we did not learn the jointly sufficient statistics, so here we assume that they are jointly sufficient statistic. And what we have actually going to do, that we will find the uniformly minimum variance unbiased estimator of the two thetas, that is g of theta, that is theta 2 minus theta 1, and the second g2 theta, that is theta 1 plus theta 2 over 2. So for these two, actually we show that these two are the minimum variance unbiased estimator, and assuming that they are the statistic which are going to use, that they are jointly sufficient statistic. So how we proceed that? We assume that, as I said, that y1, which is actually showing the minimum of x1 up to xn, and yn, which is the maximum of x1 up to xn, or jointly sufficient statistic. That is important actually, and we have to prove this actually, but because we did not learn the concept of jointly sufficient statistics, so here we assume that they are jointly sufficient statistic for theta 1 and theta 2. Now we will find that the uniform minimum variance unbiased estimators of g of 1 theta, which is actually theta 2 minus theta 1, and the second one, that is g2 theta, which is actually theta 1 plus theta 2 over 2. Now for any function of these statistics, the estimate theta 1 and g of theta 1 and g of theta 2 are unbiasedly will be minimum variance unbiased estimator. So first of all, we have to find the expected value of y1, and that is actually, we know that theta 1 theta 2 y1 into g of y1 of theta 1 theta 2 d of y1, and similarly we have also find the expected value of yn, and on the same line, that is theta 1 to theta 2 yn g of yn into theta 1 theta 2 into d of yn, and here the density is g of y1 theta 1 theta 2 and g of yn theta 1 theta 2, or the distribution of first and the nth order statistic. Now we are going to find the distribution of the order statistic, and we know that for the minimum, that is, let's say that is g of y1, and that is equal to, in general we know that n into 1 minus f of y1 raised to power n minus 1 into f of y1. So first we need f of y, and that is very simple and straightforward, f of y1, and that is equal to 1 over theta 2 minus theta 1, because they are constant. So we have to integrate it theta 1 to y1 d of y1, and that is very simple, and we get it, that is y1 minus theta 1 over theta 2 minus theta 1. So we put this result in it, and we will find that g of y1, which is equal to n into 1 minus y1 minus theta 1 over theta 2 minus theta 1 raised to power n minus 1 into 1 over theta 2 minus theta 1. And when we are going to simplify this, we will find the result n into theta 2 minus y1 raised to power n minus 1 over theta 2 minus theta 1 raised to power n. Now the expected value, which actually we want to find, that is expected value of y1, which is our main interest, that is from theta 1 to theta 2 y1 into this function, that is g of y1. And when we are going to put this one, and that is simple integration, and we will solve it, that is basically n. I just write down one step, that is theta 2 minus theta 1 raised to power n. These are the constants, so that is theta 1 to theta 2 into y1 into theta 2 minus theta 1 raised to power n minus y1. By using the substitution and solving it, we will find the result, that is actually theta 2 plus n theta 1 over n plus 1. Similarly, on the same line, we can find the distribution of the largest statistic, that is actually g of yn, and you have already familiar its result, that is basically n into f of yn raised to power n minus 1 into g of yn. And when we are going to substitute these results, that is actually n into yn minus theta 1 raised to power n minus 1 over theta 2 minus theta 1 raised to power n. And the next we need the expected value of this one, that is actually expected value of yn, and that is equal to, on the same line, theta 1 to theta 2, that is yn, and into n into yn minus theta 1 raised to power n minus 1 over theta 2 minus theta 1 raised to power n by dy. And when we are going to simplify this one, we will find the result theta 1 plus n theta 2 over n plus 1. Now we are going to find the expected value of, which is actually, we are going to prove that expected value of n1 plus 1 of yn minus y1 over n minus 1, that is for the first case, and that is actually n1 plus 1 over n minus 1 into the expected value of yn, that is actually theta 2 minus theta 1. I am writing this result by simplifying this one, and that is basically this one, and this is cancel out, and actually we are going to find that this one, and here we also n plus 1. So this cancel out with this one, and the net result will be the expected value of theta 2 minus theta 1, and basically that is equal to the g of 1 theta 1, and that is equal to theta 2 minus theta 1. Similarly, for the other one, that is basically the expected value of y1 plus y2 over 2 yn, sorry, not 2, that is yn, and that is equal to, on the same line, that is 1 by 2 into the expected value of y1 plus expected value of yn, and when we are going to substitute the results, that is 1 over 2 into theta 2 into theta 2 plus n theta 1 divided by n plus 1 plus theta 1 plus n theta 2 over n plus 1, and when we are going to simplify this result, we will find that theta 1 plus theta 2 over 2, which is basically g2 theta. So the statistic T1 steric, which is actually representing n plus 1 yn minus y1 over n minus 1, and the other statistic, that is T2 steric we call it, that is basically y1 plus yn over 2. Our unbiased estimator for g of theta 1 and g of theta 2. Therefore, they are uniformly minimum variance unbiased estimator. So as I said, that how we proceed, that first we assume that the y1 and y2 are the jointly sufficient statistic. We are not going to prove this because we did not study this module, and we assume that they are jointly sufficient statistic, and then later on we are going to find the expected value for what we are going to prove that they are minimum variance unbiased estimator. So we assume that these two statistics, that is T1 steric, which is actually the n1 plus 1 into yn minus y1 over n1 n minus 1, and T2 steric, that is y1 plus yn over 2, they are basically the unbiased estimator of our assumed estimator, which is g of theta 1 and g of theta 2. So we can say that they are minimum variance unbiased estimator.